Hello. There's been a lot of talk about orbital tourism and orbital hotels recently. And some of the articles I've read, I don't think the people who are writing them really understand many of the realities of being in orbit. So I thought I'd do a quick video, and this is called Luxury Vacation or Space Camping. And is the experience going to be this luxurious hotel room, or is it going to be closer to going and camping in the woods? So we're going to walk through a whole bunch of different things, and we'll talk about whether you can have a luxury hotel experience or whether it'll be closer to space camping. And I'm in particular going to talk about two different proposed stations. And first of all, there's the Aurora station, which is being built or planned by a company called Orion Span. And this is a fairly traditional station, so think of this as like a small version of the International Space Station. It floats out there, you go up to it, you spend your time on the station, and you come back. And the second one is a considerably more aggressive or adventurous approach. This is called Voyager Station, and it will be done by a company called Orbital Assembly. And this is a much larger station, and it has a whole bunch of individual modules arranged in a ring, and those modules will rotate. So on this station, you would have microgravity in the middle, where you would dock, and then out on the edge, you would have some degree of real gravity. And I chose these because of the differences between microgravity and artificial gravity. So let's go ahead and talk about the differences. So the first thing I want to talk about is sleeping arrangements. And you may have seen a picture like this. This is astronauts sleeping on the space shuttle in what's called the mid-deck area. And you can see sleeping bags kind of all jammed together. If you are on the ISS and you're in the US portion, each person gets their own little sleep cubicle or sleep cubby. It's a few cubic meters in size. They still have this sort of sleeping bag thing to hold them in place, because otherwise you would just float around. So sleeping bags, that sort of experience, this is clearly space camping from that perspective. Now, for artificial gravity, there's an opportunity to have an experience that's much more like a traditional sleeping experience. Now, this is a render that I've seen put around. This is clearly wrong. Nobody is going to build an orbital habitat like this. You simply don't have that kind of room. But you can probably have a fairly normal bed, a bed that you sleep on top of. Because of the artificial gravity. So from that perspective, I think you can probably come pretty close to the luxury hotel sort of experience. Let's move on to food. In microgravity, well, these are the kind of foods that you would see in ISS right now. They're all freeze-dried. Typically, you add water, either hot or cold, and it gives you food like that. You might have snacks and condiments, also prepackaged, and that's from the US side. The Russian side is very similar. Lots of freeze-dried stuff and a fair bit of canned stuff. And in fact, all of this food is very similar to what you might actually take if you went on a camping or a hiking trip. So I'm going to definitely call this space camping. Now, if we go to an artificial gravity situation, we have fewer constraints. We aren't worried about crumbs floating around to the same degree, so maybe we could go with more reasonable food. But there's some problems. Fresh food is heavy. There's lots of water in it, and it's therefore pretty expensive to launch. It also spoils pretty easily. Which means you either need to eat it quickly or you need some sort of refrigeration. Unfortunately, refrigeration takes a lot of power, and you do not have a tremendous amount of power aboard these stations. It also can generate a fair bit of heat, and getting rid of heat in an orbital situation is kind of hard. So all of these things are a bit problematic. Now, ISS specifically has these problems because it doesn't get resupplied for fairly long periods. If you are running an orbital hotel, you probably have people showing up every week or every 2 weeks, something like that. So maybe you can afford to lift a little more of this because you're doing it more often. But still, that's going to be difficult. The other problem is you really cannot deal with cooking fumes and cooking odors. You don't have exhaust fans. You can't just pump it outside. And that is going to be very problematic to deal with in any station, any sort of cooking that generates fumes. So I think that's probably the big reason. You're not going to see a typical restaurant style food in an orbital habitat, at least unless it gets really, really big. So you're still space camping. You're not eating normal food, normal hotel food. For drinks, well, typically astronauts will be drinking out of pouches, but pouches can be pretty versatile. You think we get juice in pouches, maybe milk in pouches, water in pouches. All of that's pretty straightforward. For soft drinks, both Coke and Pepsi actually flew these prototype soft drink dispensers on the space shuttle. They weren't really very popular amongst the astronauts because in a microgravity environment, carbonation isn't very nice. If you drink soda on the ground, the liquid goes to the bottom of your stomach and the carbonation goes to the top. And if you have too much left over, you can burp it out. In a microgravity situation, all of it just stays together, and it apparently tends to be fairly uncomfortable. So these weren't very popular. You could do the carbonated ones in the artificial gravity situation. They would probably be fine. For alcoholic drinks, it's kind of the same situation. For microgravity, you probably would want to limit yourself to liquor and wine. But if you have artificial gravity, you can probably add in beer and champagne and those sort of things as well. So all of them are going to be kind of pricey. As I said, lifting things up into orbit is expensive. And these are liquids, they're heavy, the bottles are heavy. But on the other hand, if you're going on an orbital vacation, it's probably very pricey anyway. So maybe this is not that big of a deal. So you can probably get pretty close to a luxury hotel, or at least give people a fair number of choices with what they drink. Another drink, coffee, and of course people care a lot about coffee. Interestingly, there is an espresso maker that has been flown on the ISS, and reportedly it's pretty good. And in fact, they have also developed a very strange looking cup for the coffee. And basically the problem you have in microgravity is the fluid, doesn't want to go where you want it to go. Now with something in a pouch, that's great. You can just suck it in through a straw. Doing that with very hot coffee is not a very good thing. So they came up with this cup, and the very specific shape uses the surface tension of the coffee to hold it in the right position, and then you can actually sip out of the cup. And here we can see this actually being tested on ISS, and you can see coffee is all towards one end. So looks like this is actually a pretty well solved problem. You can do good coffee on the ISS. So luxury hotel. What about water? Well, water is very interesting. There's a saying on the ISS. On the ISS, we turn yesterday's coffee into tomorrow's coffee. And yes, that means exactly what you think it means. There are two sources that can be recycled into potable or drinkable water. And the first is people sweat and they breathe out water vapor, so that can be condensed out of the atmosphere using something pretty much like a dehumidifier. The other source is the astronaut's urine, and that goes through this long process. This is the first page of the process. This is the second page of the process. And this is the equipment that is actually required to do it on board ISS. Now, reportedly, from the astronauts, the water actually tastes just fine if you can get over the psychological part of where it actually came from. The Russians also ship up water on their Progress supplies. Comes in these aluminum containers with these plastic interior bladders. So it's not clear to me, if you're running an orbital hotel, which approach you would take. I think you need something to get water out of the air, and that's pretty much a requirement. Do you need to recycle urine? Probably, I think. I think you're probably not going to be able to bring up enough water to support things, but I don't know. Maybe you'd choose to devote that. So that, I don't know whether it's camping or not. We'll have to see how that shakes out. For showers, if you're doing microgravity, back in the 70s when they flew Skylab, NASA actually had a shower on board Skylab. So you'd get in this container, you'd seal it all the way at the top, and then you could kind of spray water against your skin. Remember, in this shower, because you don't have gravity, the water does not fall to the bottom. It just kind of sticks to you and the walls and everything else. Apparently, this worked quite well. Astronauts actually liked being able to take a shower, but it took them about 2 hours from start to finish. Because you spray the water on, and then you have to get the soap on, and then you have to spray water on again and suction it off with a vacuum, and then there's a bunch of cleanup at the end. So you could do this in microgravity. It takes a fair bit of water, but on ISS they choose not to. So they have more of a, think of this more like a sponge bath. So you have a no-rinse body bath, and you add hot and cold water to it, and then you essentially just use this to kind of rinse yourself off. For hair, they have something similar. It's a no-rinse shampoo sort of thing. You put it in, massage it around, kind of blot it off, and just let it dry, and that kind of works. But this really is space camping. This isn't a shower the way most of us on the Earth think of a shower. In artificial gravity, well, I don't know. Maybe you can do a real shower. You could do something that looks more like a normal shower. But water's very heavy, so it's hard to get a lot of water up, and it's going to be hard to recycle this. You're going to need something special to be able to recycle that water. On the ISS, the ration for astronauts is 11 liters a day. Average shower on the Earth takes about 65 liters. So it would be a lot more water than is currently being used. So I don't think we're going to see standard showers. Maybe you could do something very low flow that kind of works. More like what you'd see, I guess, on a submarine, where they've been very limited with water, or one of those sort of situations. You're also not going to see bathtubs. You're not going to see hot tubs, and you're not going to see pools. The cost to get that much water up and then treat it and do all of that is very likely prohibitive. You're also probably not going to see the sort of spa experience that's all around this. So I think it's still mostly going to be space camping. Bathrooms. Well, this is a fun one. This was the standard toilet on ISS. Used both in the Russian and US ends of the station. And basically you have this seat you lift up. It uses air currents to move solid waste down into that can. And then there's a urine hose with the appropriate attachment that is used to collect urine. And it also uses essentially a vacuum to pull it in. At the US end, they've created a better system, kind of a more advanced version of that, but it's still basically the same concept. So urine and solid waste are separate. This is space camping. If you think of, the difference between a normal bathroom and using an outhouse at a campground, this is probably worse than that. For artificial gravity, well, I guess conceivably you could do real toilets, but wow, they use a lot of water, and even worse, how are you going to deal with the sewage? It's going to be very problematic. Maybe you can do a composting toilet. Maybe that'd work. There are also incinerating toilets that essentially heat up and turn all the waste to ash. That could be possible if you had enough power, and these take a lot of power. But if you could do that, all the moisture would go in the air. You already have a system to pull water out of the air, so that might actually work if you had the power. But we're not going to see something normal. In either of these systems, and in microgravity, odor control is also going to be kind of problematic. It's just not the normal experience people would expect. There are no exhaust fans. So I think this is still space camping. Recreation. Well, obviously in microgravity, we've all seen these sort of things from astronauts, and I think this is going to be a big draw. And both stations actually have microgravity. In the first station, everything is microgravity. In the artificial one, you have microgravity in the middle. And I would think you definitely want to devote space to allow time for these sort of activities. That seems like one of the absolute reasons you would want to go into orbit. There might be development of some orbital sports, also in that same sort of area. That looks like that could be a lot of fun, and I think people would like those sort of things as well. And there's also the wonderful fun of eating your food in zero gravity, which astronauts seem to be endlessly amused by, and I think most people would be endlessly amused by. So at least if you're in microgravity, you'll have that opportunity. Some other choices, well, looking at the Earth, that seems like something most people would want to spend a fair bit of time doing. This is probably better in the microgravity station because it will stay stable. Looking out in the window, Earth is just going to be in the same location. In the artificial gravity one, the ring around the station with all the modules is going to be rotating all the time. So if you had windows in your module, you could look at the Earth, and then there'd be, a short period of time, and then the Earth comes back, and then goes away, and comes back, and goes away, and comes back, and goes away. And it may be if you're rotating fast enough, that doesn't really work at all. So you might be stuck doing it from the microgravity part in the middle. In addition, recreation is possible. These are all from ISS. There's a treadmill with bungees that holds you down. There's a exercise bike, which is probably pretty close to what exercise bikes feel like on the Earth. And there are some possibilities of doing some sort of weightlifting equipment. I don't know if you'd bother doing this if people are coming up for a short stay, but maybe they'd want to do this sort of thing, and that's pretty simple. And then finally, there are more traditional recreation choices. You could watch TV, you could use the internet, or you could read. At least with ISS, there isn't that much bandwidth for the internet and for TV, so you may be limited in your choices compared to what you'd have at home. Spacewalks. Well, spacewalks look really interesting, and I could see there being a lot of interest in wanting to do that. It would certainly be a more exciting experience than just being inside. Unfortunately, spacewalks require a lot of training, or at least in the current world, they require a lot of training. So I think it's unlikely for spacewalks to be something you would offer to people who have come up to visit your hotel. On the other hand, there are other activities on the Earth There are activities like scuba diving, which we think of as a fairly skilled activity. But if you go to like Hawaii, you can take a really quick scuba diving certification course and you can go and dive. So I don't know, maybe someone will come up with this and people will be willing to take the risk to do something that really obviously is something that's very, very cool. Sex, of course, sex is going to come up with on this. We know there was one married couple that flew on shuttle. They kind of hid that they were married until it was too late. We have no reports of any specific activity. The shuttle cabins are pretty tiny, but it is true that the middeck is pretty separate from the flight deck. I don't really know. Procreation is likely a very bad idea. We don't know about human embryonic development without gravity. And we don't know even how it would work with less than normal gravity. So in either case, that's probably something that is to be avoided. To go on to some more medical stuff, I need to talk about motion sickness. And if you're going to a microgravity environment, about 50% of the people who do that get what's called space adaptation syndrome or space motion sickness. It generally lasts 2 to 4 days. That would be kind of unfortunate if you went on a vacation for a week. You might spend half of your time feeling at least mildly motion sick. There are drugs like antihistamines that help. Unfortunately, they tend to make people a little woozy and a little tired. That's not great either. Not doing sudden moves also seems to help. But if you remember that recreation part where you do gymnastics and spin around or try to play sports or do that sort of thing, all of those things kind of involve sudden moves and rotation. And those are probably not going to be possible if you have this syndrome. So that's kind of not great. I want to talk about a specific person. So Jake Garn flew on shuttle and he got very sick for the whole time. And so much so that levels of sickness are now measured using the Garn as a unit. And the reason I brought him up was not to make fun of him, but to note that Garn was a very experienced pilot. And he had 17,000 hours of piloting military aircraft before he went up. So it's really not clear who gets this and who doesn't. Sometimes people you think would be absolutely immune get very sick. Now, obviously, we don't get this if we're not in microgravity. Oh, sorry. And this is space camping. Or actually, space boating is probably better. If you've ever been out on a boat, gotten motion sick, and then been stuck on the boat for 4 or 5 hours, you know what this can be like. And that's really not a whole lot of fun. If we go to artificial gravity, things are different. We don't have the microgravity issues. But there's this thing called the CC illusion. And basically what happens is you're not actually in gravity on this sort of station. You're standing and your body is rotating around and your feet are rotating faster than your head. So you're both pulled down and being rotated at the same time. And if you've ever been on carnival rides that kind of rotate you around, you may know that if you move your head in weird cases, you can get motion sick very quickly. So that same sort of thing can happen in these environments, at least from the tests that we have done looking at these sort of things in the Earth gravity field. The smaller the radius, so the smaller the ring and the faster you rotate, the worse the effect. And there have actually been some studies that have looked at what the behavior is in the Earth gravity field and has come up with some ideas of what will probably be comfortable for people in orbit. It looks like people may be able to acclimate to this sort of thing ahead of time. Certainly, they've been able to do that with Earth-based experiments. It's possible that going from the artificial gravity way out at the ring to microgravity in the middle may be problematic. People may not do well going from one to the other. And that's kind of unfortunate for the artificial gravity station, because clearly you want to spend some time in microgravity and do gymnastics and that sort of thing, and that may be the best spot for viewing the Earth. So that might be a problem, might not be. One of the big problems is we actually don't have real research in space to look at this. So it might be that you build a station that has artificial gravity and things just might be fine, and this may not affect people really much at all if you acclimate ahead of time. It may be, conversely, that you build a station like this and people typically get sick and it just doesn't work very well. We simply do not know. If you want to know more about artificial gravity stations in general and maybe how the motion sickness might manifest, Project Rho, as is generally true, has a great page. Both medical information and different stations and all sorts of fun stuff. So head on over to there if you want to know some more. I still think this probably ends up being space camping, or a little bit like space boating. I think even just the going from artificial gravity to microgravity and having this isn't going to be like a hotel that is just on the ground. It's going to be a little different. Microgravity gives you this other fun effect. So the lack of gravity pushes fluid into the head. So in a normal gravity field, we spend a lot of time standing up, and the gravity pulls fluid down into our bodies, down towards our feet. And in fact, we have systems that are kind of designed to get fluid out of our feet, out of our lower limbs. You go into microgravity and you no longer have that gravity field. So some of the fluid in your body migrates up, gives you more fluid in the head, and feels kind of like a low-grade head cold. One of the side effects of this is it reduces the ability to smell and taste significantly. If you've ever had a cold, you know, guess what? You can't taste very well, you can't smell very well. And if you've ever seen pictures on the ISS of where the astronauts and cosmonauts eat, you will see that there are always condiments there, and there is always hot sauce. And this is because food just does not have much flavor when you're in microgravity because of this. This really does not go away. It's not something you acclimate to. Maybe you acclimate to food not tasting like food, but it really doesn't get much better. So this is really space camping. Now, there have been experiments to try to counteract this. Here's one. This is called a negative pressure lower body experiment. Basically, you have this weird thing attached around your body. It seals, and then you try to pull a vacuum and see if you can pull fluid down farther. I don't know what the outcome of this one was, but it's not something that's currently used with astronauts. So my guess is it's really not that practical. And you're certainly not going to put your guests into this sort of get-up. If you did, it would still certainly be space camping. Noise. Well, it turns out that being in orbit is a noisy place. And I actually went and found a study that looked at the amount of noise in ISS. And ISS in general, in the different modules, the environment is between 60 and 80 decibels. So 60 decibels is normal conversation, like the sound of an air conditioner running, those sort of things. 80 decibels is like an alarm clock or a garbage disposal. So actually fairly loud. And if we look at this chart, we notice the green dots say HPD, hearing protective device, recommended. So below that, you would be fine. And this is for a 16-hour exposure. So basically, during the day, if it was less than 60 decibels, you would be fine. You notice that nothing is really at that level. Pretty much everything is either in the hearing protection recommended or hearing protection required parts. So it's loud. Now, it is true that ISS has a lot of machinery kind of in the main modules. It has labs that are also pretty loud. So this might be a little higher than what you would see on a more leisure-based station, but you still need quite a bit of machinery. So this might be problematic. In the sleep environments, they've made a specific effort to have them be quieter. So they're between 50 and 60 decibels. You notice that if you look at the red line in the second chart, that's enough so that your ears will likely get back to normal if you had a little too much exposure during the day. It's not quite down low enough so that it's not going to affect your sleep. And in fact, it's pretty true that astronauts in general do not sleep particularly well when they are on orbit. So this is just something that we are going to have to deal with in orbit. So, 50 decibels, quiet office or refrigerator. So it's pretty quiet, but still space camping. That luxury hotel room you go to, which has that really nice ventilation system and is really quiet, you're not going to get that in orbit. Laundry. Well, on the ISS, there's no laundry. Astronauts currently wear their clothes until they get too smelly, and then they pack them up for disposal. That may mean that the head congestion is a bit of a blessing in disguise, that you actually can't smell yourself and other people quite as well as you could in a normal situation. This might not be that big of an issue in a vacation situation. People might bring up enough clothes that they can just change clothes, and maybe you can do a little better with showers. So I don't think is a problem for clothing. It's probably a problem for bedding and towels and that sort of thing. NASA did commission a washer-dryer prototype in 2011. As far as I can tell, they didn't fly it. And Russia has reportedly developed one that used carbon dioxide compressed enough to become a liquid and then use that. So it's kind of like a dry cleaner. From what I can tell, that has also never been flown. So definitely no laundry, space camping. So that's all that I wanted to talk about. We had some things that are luxury hotel quality, but I think if we look at it, space camping is really much more likely what the experience is going to be like. It's kind of like on a campsite, you can't go anywhere else, and you have all these things that are just quite a bit different than what you are used to. So we'll see. There may be a lot of people who are interested in space camping, but it's not going to be the luxury experience that some people have said. Thanks for your attention, and if you liked it, please subscribe.